Good morning, friends. In last lecture, we discussed about the reflection of a light and also the reflection of a light by a spherical mirror. And also we did the equation of the magnification and also the ghost formula or the mirror formula. Okay. Now, the second phenomena of the light is that the refraction. Refraction of the light already we learned in 10th standard. What is the refraction? When the ray of light enters from one transparent medium to the another transparent medium. Here, keep in mind that the ray of light must be obliquely. That means not normal to the surface. At this time, what's happened? The direction of the light is changed from the surface separating the two medium. For that purpose, we use the figure like this way. That is the PQ. PQ is the surface separating the two medium. Now, I do the perpendicular at point B on this surface. That is the medium 1 and that is the medium 2. Here the refractive index is N1, the refractive index of medium 2 is N2. Now, the ray of light is entered. Initially, it is traveling in medium 1. AB is the ray of light. Actually, that is the incident ray. Now, at point B, this ray is entering another medium. So, original direction of the path is this. But the medium change, therefore, this ray is not traveling the straight path, its direction is changed. And that is the refracted ray. That is the refracted ray. The angle made by the refracted ray with the normal, that is the angle of refraction, that is the R, and that is the angle of incidence, that is the I. Again, according to a definition, when the ray of light incident normally from one transparent medium to the another transparent medium, so its direction is changes at the surface separating the two medium. This phenomena is known as the refraction of a light. Clear this? Okay. Now, in figure AB, what is the AB? AB is the incident ray. BC is the refracted ray. Now, the angle AB, that is the AM and that is the AM. ABM. Angle ABM is the angle of incidence. Angle of incidence. That is denoted as I. Now, angle NBC, that is the angle of refraction. Angle NBC, angle of refraction, that is denoted as small r. While N1 and N2 are refractive index of medium 1 and medium 2 respectively. So that is shown in the figure. AB is the incident ray, BC, refracted ray, angle ABM, that is the angle of incidence, angle NBC, angle of refraction, and MN is the normal drawn at point of incidence. Clear this? Okay. Now, what are the laws of refraction? Laws of refraction. First law. What is shown in the figure? Incident ray, refracted ray, and normal at point of incidence are in one plane. Again, the incident ray, refracted ray, and normal at point of incidence are in one plane or the same plane. Here, this plane is the plane of our green ball. That is our plane. All these three things, incident ray, refracted ray, and normal, are in one plane. So that is our first group, incident ray, refracted ray, and normal at point of incidence are in same plane. Are in same plane. That is our first. Now the second law is there. What is the second law? Now first we discuss about that. The medium in medium 1, the effective index is N1 and angle of incidence is I, while the angle of refraction is in medium 2. Therefore, for given to medium, the ratio of sine of angle of incidence to the sine of angle of refraction is remain constant. Again, the ratio of sine of angle of incidence to the angle or sine of angle of refraction remain constant, and this constant is known as the relative refractive index of given to medium, and this statement is known as the Snell's law. This statement is known as Snell's law. Now second group, for given to medium, the ratio of sine of angle of incidence to the sine of angle of refraction remain constant. This constant is known as relative refractive index of given to medium. Again, for given to medium, the ratio of sine of angle of incidence to the sine of angle of refraction, this ratio is remain constant, and this constant is known as the refractive index of given to medium. And this statement is known as Snell's law. This statement is known as Snell's law. Okay. Now, if in medium 1, angle of incidence is I, and in medium 2, angle of refraction is R. Then sine I upon sine R is constant, and this constant is denoted as into 1. That is denoted as into 1. Here, into 1 is refractive index of medium 2 with respect to medium 1. Now, from this statement, now we write down in equation form. If in medium 1, the angle of incidence is R, and in medium 2, the angle of refraction is R, therefore the ratio of their sine value, sine I upon sine R, is equal to constant, and this constant is denoted as into 1. Into 1 is refractive index of medium 2 with respect to medium 1. That is the refractive index of medium 2. Here, in support with the medium 1, that means with respect to the medium 1, that is denoted as into 1. Now, refractive index of given medium depends on types of medium, its temperature, and wavelength of light. Wavelength of light. But not depends on angle of incidence. That means the refractive index of a given medium depends on types of medium, also its temperature and the wavelength of incident light. Not depends on the angle of incidence. So these are the two laws of refraction. One is the incident ray, reflected ray, and normal at point of incidence I one of them. And second is that the ratio of sine of angle of incidence to the sine of angle of refraction for given two medium is remain constant. And this constant is known as refractive index of given two medium. Now, the 2 marks most important question is that write Snell's law and obtain its general form. Frequently, this question is asked in board exam for 2. Okay. Already we discussed about the Snell's law in laws of refraction. Second law is our Snell's law. Again, we have to write down here the statement of the Snell's law. For given two medium, the ratio of sine of angle of incidence to the angle of refraction is remain constant, and this constant is known as refractive index of medium 2 with respect to the medium 1. Therefore, the statement is that means the Snell's law. For given two medium, the ratio of sine of angle of incidence to the sine of angle of refraction R is constant. This constant is known as relative refractive index of given two medium. Therefore, sine I upon sine R is constant and is equal to into 1. That is equation 1. This is statement of Snell's law. Now the general form of the Snell's law is that n1 sin I is equal to n2 sin R we have to obtain. That is the Snell's law. Okay, now for that purpose, first we define the absolute effective index and also the relative effective index. On the basis of these two definitions, we are obtaining the general form of Snell's law. For that purpose, first we write down absolute effective index. Absolute effective index of a medium is defined as the ratio of the velocity of a light in vacuum to the velocity of a light in a given medium is known as absolute effective index of a medium. The ratio of velocity of light in vacuum to the velocity of a light in a given medium is known as absolute effective index of a medium. Therefore, n is equal to C upon V. N is equal to C upon V, where C is equal to 10 to 10 is to 8 meter per second. That is the velocity of a light in vacuum. Again, what is the absolute effective index? The ratio of velocity of a light in vacuum to the velocity of a light in a given medium is known as absolute effective index of a medium. It is denoted by n. N is equal to C upon V, where C is equal to 10 to 10 is to 8 meter per second. Okay, now relative effective index. Relative effective index. So, how we define the relative effective index? For that purpose, here in medium 1, the velocity of a light is v1, and in medium 2, the velocity of a light in medium 2 is v2. Therefore, the ratio of velocity of a light in medium 1 to the velocity of a light in medium 2. The ratio of velocity of a light in medium 1 is v1 to the velocity of a light in medium 2 is v2 is known as effective index of medium 2 with respect to medium 1 n to 1. Therefore, n to 1 is equal to V1 upon V2. Now in absolute effective index, other medium is not present. For that purpose, as a reference medium, we consider the vacuum. But here the two medium are given, the medium 1 and medium 2. Therefore, we will take that the velocity of the light in medium 1 is V1 and in medium 2 is V2. Now the ratio of V1 to the V2 is known as the effective index of medium 2 with respect to the medium 1. So n to 1 is equal to V1 upon V2, that is equation 2. Now we can add this equation. That means this right hand side of equation 2 is multiplied and divided by c. Therefore, this take this form c upon v2 into v1 upon c. Here c upon v2 from our definition of absolute refractive index. So that is the velocity of light in vacuum to the velocity of a light in medium 2. That is into, that is absolute refractive index of medium 2. Of medium 2. And c upon v1 is equal to n1 is absolute refractive index of medium 1. Therefore, n21 is written as n2 into 1 upon n1. That means the n2 upon n. That is our equation number 3. That is our equation number 3. Now we substitute this equation in statement of Snell's law. Earlier we have written the statement of the Snell's law is sin I upon sin R is equal to into 1, but into 1 is equal to into upon n1. Therefore, substitute in equation 1. Equation 1 is sin I upon sin R is equal to into 1. But equation 3 is into 1 is equal to into upon n. Therefore, n1 sin I is equal to into sin R. So, there is the general form of Snell's law. This is general form of Snell's law. This equation is very easy to derive only from the definition of absolute and relative refractive index with the medium. We can obtain this equation of general form of Snell's law. Okay, now after the discussion of the Snell's law, sometimes the question arises in our mind that when the ray of the light is entered from one transparent medium to the another transparent medium, the reflected ray always bend towards the normal? No, that is depends on types of medium. So here we discuss about that in which condition the reflected ray bends towards the normal and which condition the reflected ray is moving away from the normal. For that purpose we are using the Snell's law. For that purpose, if n1 is less than n2. Before starting, here if n1 is less than n2, therefore from Snell's law, sin I upon sin R is equal to n2 upon n1. Here the value of n1 is smaller than the n2, therefore this ratio is greater than 1. Therefore sin I greater than sin R. Therefore I is always R. I is always R. That means in this case, here the angle of incidence is greater than the angle of reflection. In this case, as the ray of light is traveling from ray transparent medium to the denser transparent medium. For that purpose, thus, if ray of light enters from the transparent medium to the denser transparent medium, the refracted ray moves towards normal. Moves towards normal. Now the second case is that if N1 is greater than N2, N1 is greater than N2. So from Snell's law, sin I upon sin R is equal to N2 upon N2. Here N1 is greater than N2, therefore this is less than 1. Therefore sin I is less than sin R, therefore I is less than R. In that case, the angle of refraction is greater than the angle of incidence. Like this manner, there is our PQ, there is our normal. The incident is this AB. There is the angle of incidence. Here, there is the medium one, there is the refractive index and one. Here, medium 2. And the refractive index is N2. Here condition is N1 greater than N2. At that time, the refracted ray is bends away from the normal, this way. So that is the angle of refraction. Here, there is the denser medium. That is the ray medium. Here, there is the ray medium. There is denser medium. So we can add here the description. Thus, when a ray of light enters from denser to the ray medium, the refracted ray moves away from the normal, away from the normal. So these are the conditions in which case the refracted ray bends towards the normal or moving away from the normal. That is depends on the types of medium, not depends on the angle of incidence. Now listen here, there is enter from ray medium to the denser medium, and here there is the denser to the ray medium. Now, sometimes the question arises in our mind that which medium is the ray and which medium is denser. The medium having the large value of refractive index is known as the denser medium. The medium having large refractive index is known as denser medium, while the medium having small refractive index is known as rare medium. So there is the two type of the medium, rare and denser. There is we can know from the value of its refractive index. So when the ray of light is traveling from there to the denser, the refracted ray is moving towards the normal, and denser to the ray moving away from the